Okay, so question 24. So we've got vectors here. AB is parallel to DC, so we know that this line and this line are parallel. They've put in that it's vector little p from D to C. So they told us that here. Now they have not put it on here, but the vector A to B is 5p. So this is 5p. So from here to here is 5p. Now they also tell us that DA, so from D to A, that's vector 2q minus p. I tend to write things on there so that I don't have to keep referring back to the text. So I find it a lot easier. So it says show that C to B is 2q plus 3p. So C to B. Okay, so from C to B. Now we can't go directly from C to B because we have no vectors. But we do have the vectors going around the long way. Okay, so from C to D would be little p, and to that, okay, so from C to D would be, from C to D will be minus little p because we're going in the opposite direction. From D to A will be 2q minus p, so this would be 2q minus p, and then across the top I know is plus 5p. Okay, so they're all my vectors. So now I just need to simplify this. So minus p will give me minus 2p plus 2q plus the 5p. So we have plus 5p. Now this can be simplified. We have minus 2p plus 5p. So that will give me 2q plus 3p. Okay, and that does give me that. So I know I'm okay. So the next part of the question, M is the midpoint of AD, A to N to B is a ratio of 2 to 3. Okay, so here A to B is 5p, A to N is 2 to 3 in relationship. Okay, so 2 to 3 would be 5 shares, if you like. So if A to B is 5, 5 divided by 5 is 1, so 1 share is P. Now A to N is 2 shares, so I know that this is 2p, so this must be 3p, because 2 to 3. Okay. Show that MN is parallel to CB. Okay. So what they want to prove is that M to N is parallel. So they're saying that this is parallel to this, and we have to show it. Now M to N, I can't go directly to it, so I have to take this root here. Now M is the midpoint, so it's going to be half of this. So half of 2q minus p would be q minus half p. So this would be q minus 1/2 p plus a to n is 2p. So a to n is 2p. Okay, now we can simplify this, so we get q, now minus half p plus 2p gives me minus 1.5 p. Okay, so this gives me m n. Now we know c to b is 2q plus 3p. C to B, I better put the arrows in here and the arrows in here, equals 2q plus, 2q, no, I was right. So this would be, this would be plus 1.5p. 2p take away p plus 1.5p. I do beg your pardon. So c to b is 2q plus 3p. Now I can see that this is half of this. So I can say that q plus 1.5 or 1.5p equals 2q plus 3p, all divided by 2. So I can put, therefore, the one thing that I do know is that if we have parallel lines of the same length, they will have the same vector. Okay? If they're parallel lines of different lengths, they will be multiples of that vector. So for example, if I have two lines that are parallel, okay, they're parallel here, and this line is 3 times longer than that. If this is A, this will be 3A, okay, because they're parallel. So I can now say that MN is parallel to CB. Okay, a bit fiddly, but if you understand that parallel lines of same length have the same vector quantity, then parallel lines will have the same vector but in multiples, okay, as we did up here. Okay, so we'll look at the next question. Okay, so question 25a. On this grid, draw the graph of 1 plus sine x, and they've drawn the graph of y equals sine x here. Now, you'd have to sketch it rather than draw it, but it's sine x plus 1. So all that's happened is that this graph has moved up 1. Okay, like a y equals mx plus c. The graph can move up or down accordingly, and the c value is the y-intercept. Now this is going to be exactly the same because it's going to cut at 1. So everything is going to be raised by 1. So we'll have a point here, we'll have a point here, we'll have a point here, we'll have a point, we'll have a point here, we'll have a point here, and we'll have a point here. So our graph will do this, okay, roughly. Okay, it would actually just kiss that point there. Okay, so if I just take this bit out here. Okay, so everything is the same, it's just been lifted by 1. That's all there is to it. Now the next one, we again have y equals sine x, but this is y equals 2 sine x. So what that means is that the extremes are lifted. Okay, the high points and the low points are lifted or dropped. So here at 90, this is our high point, it's actually going to come up to 2, and here it's going to go down to 2. So our graph will come all the way up here, will still come down at 180, will just kiss here and then come up. Okay, so 2 sine x means that these high points are lifted and dropped. Okay, there's a difference between y equals 2 sine x and y equals sine x 2. So here what's happened is the high points and the low points are extended. Okay, if it helps, this sort of question tends not to come up too often, okay, but it is worth knowing. Okay, so I'll stop at that point. I think there's one more question, so we'll go on to that question in the next one.